This video is on the basics of atomic structure, a topic which I am sure has been covered multiple times in your science careers. It can be broken down simply into the statement, which happens to be Latin for atoms or a whole divided into three parts, and we shall use this atom as an example to demonstrate the three parts. The first part is in purple, and those are the protons, and they are positively charged. And notice they are inside the blue circle. The blue circle represents what is called the nucleus of the atom, or the center of the atom. In green, we have the neutrons, also in the nucleus, and they are called neutrons because they have no charge or are neutral. Outside the nucleus, we have the red particles. Those are electrons, and they are negatively charged. With the protons and neutrons being inside the blue circle, inside the nucleus, they are frequently called nucleons. Protons are given a mass of 1 atomic mass unit, or AMU. Neutrons also weigh 1 atomic mass unit. Electrons weigh 1/2000th of an atomic mass unit, so a valid assumption for AP chemistry is that electrons have no mass. The number of protons is defined as the atomic number. The atomic number defines what the element is. All oxygen atoms have 8 protons. All uranium atoms have 92 protons. In a neutral atom, the number of protons equals the number of electrons, so the overall electrical charge is 0. When the number of protons does not equal the number of electrons, then we have what is called an ion. An ion is basically a charged atom. If the number of protons is greater than the number of electrons, as we can see in this example, the number of positive charges is greater than the number of negative charges, so the overall charge will be positive, and that's called a cation. In this example, the number of electrons is greater than the number of protons, so the number of negative things is greater than the number of positive things, so the ion will be negatively charged, and that's called an anion. The overall ionic charge of an ion is equal to the number of protons minus the number of electrons. So in this example, we have 6 protons, we are subtracting 7 electrons, and so you get an ionic charge of -1, so this is an anion. Now in the nucleus, the number of protons plus the number of neutrons is what is called the mass number. So in this example, we have 6 protons and 6 neutrons, so this has a mass number of 12. So let's take a look at 2 different atoms. The one on the left has 6 protons, and so it must be carbon, because by definition, carbon has 6 protons. The one on the right has 6 protons, so it by definition must also be carbon, because if you have the same number of protons, which in this case is 6, it must be the same element. If we count the neutrons, we see the one on the left has 6 neutrons, the one on the right has 8 neutrons. That is different. If you have a different number of neutrons, you have a different mass number. So the mass number of the carbon on the left is 12, the one on the carbon on the right is 14. These are what are called isotopes. An isotope are atoms of the same element with different numbers of neutrons and thus different mass numbers. And so when talking about isotopes, we have to identify which is which, and that is done by putting the mass number after the name of the element. So we would say we have carbon 12 and carbon 14, but since writing out 6 letters is a lot, we will mostly use the symbol with the mass number in the upper left-hand corner. Carbon 12 and carbon 14. Now the mass number is a whole number, but the atomic mass, which is the number you see in the periodic table, is not a whole number. The atomic mass is a weighted average of the naturally occurring isotopes of an element. Units. If you're talking about a representative atom, you would say AMU, but most of the time we talk about the molar mass. So if you have more than one atom, you're talking grams per mole. Now when doing a weighted average, this takes into account the relative abundance of each naturally occurring isotope, the relative abundance being how many of that specific atom are present in a sample. It will be a percentage. Once you calculate the weighted average, the one thing you do not do is divide by the number of different isotopes. That's because the weighted average takes into account the relative abundance. And as a double check, the answer will be greater than the lowest mass number and lower than the highest mass number. If you get something outside that range, you did something incorrectly. And the best thing to do is to do an example. So we'll talk about silicon, which has 3 naturally occurring isotopes, and you're asked what is the atomic weight of silicon. We know the isotope, we know the mass number, we know the relative abundance, and if it is in percentage form, we can divide it by 100, and then we can use that to calculate the contribution of that isotope, which is called the relative weight. If you multiply the mass number by the relative abundance divided by 100, that will equal the relative weight. So we start with the first isotope, which is silicon-28. It has a mass number of 28. We're going to multiply it by the 92.23% divided by 100. And when you multiply those two numbers together, you get 25.82. We go to the next isotope, silicon-29. There's the mass number. There's the relative abundance divided by 100. When you do the math, that's the value you get. We go to the third isotope, which has a mass number of 30, relative abundance divided by 100 of 0.0309. Do the calculation, and we get this value. Add them all up, we get 28.107. Need a unit. I'm going to use grams per moles. But one of the things I noticed, my double check, is that 28.107 is greater than 28, but less than 30. I also know that since more than 90% of the mass is due to the silicon-28, I would expect the answer to be closest to 28, and it is. So I'm pretty confident that this is the correct answer. Now you can also work this backwards. If you know the mass numbers and you know the atomic weight, then you can work backwards to get the relative abundance of isotopes. So here we have 2 isotopes of copper, 63 and 65, and we know that the atomic weight is 63.55 AMU. Since we don't know the values of the relative abundances, we'll let X equal the relative abundance of copper 63 and Y be the relative abundance of copper 65. That gives us 2 variables, so we're going to need 2 equations. Well, we know that the total of the percentages has to equal 100%. We'll call that equation 1. And the summation of the mass number times its relative abundance has to equal 63.55. That's equation 2. So we set the equations up, and we're actually going to rearrange equation 1, and you get X equals 100 minus 1. So I can take that 100 minus 1 and substitute it into equation 2, and so now equation 2 looks like this. I distribute the mass numbers, and the equation looks like this. I can add on the left side and put it all over one denominator. So now the equation looks like this. Multiply both sides by 100. Subtract the 6300 from both sides. Subtract the 63y from the 65y. I get 2y equals 55, or y equals 27.5%. Well, y is equal to the percentage of copper 65. We know that x is 100 minus y, so plug the value in, and you get 72.5% equals the percentage of copper 63. So we've worked backwards to get the relative abundances. So to review, once again, a topic that you've reviewed multiple times in your careers, protons are positively charged particles found in the nucleus. Neutrons are uncharged particles found in the nucleus. Electrons are negatively charged particles not in the nucleus. Protons and neutrons are called nucleons. We define the mass of protons and neutrons as 1 atomic mass unit, and electrons, for all intents and purposes, have no mass. The atomic number is the number of protons, and an element is defined by the atomic number. In a neutral atom, the number of protons equals the number of electrons. If the number of protons does not equal the number of electrons, the entity is referred to as an ion. If the protons outnumber the electrons, you will have a positively charged ion. That's called a cation. If the protons are less than the electrons, you'll have a negatively charged ion known as an anion. And the ionic charge equals the number of protons minus the number of electrons. The number of protons plus the number of neutrons is known as the mass number. Atoms with the same number of protons but different mass numbers are isotopes. The weighted average of the mass numbers of the naturally occurring isotopes is the atomic weight. If you're talking about one atom, you'll use AMU as the unit. Otherwise, you'll use the molar mass in grams per moles. Remember that the weighted average takes into account the relative abundance of each naturally occurring isotope. So now you can jump for joy because you can go practice some of what you learned.